All right, guys, we're gonna go on to chapter 9, which is on two proportions and two means and all of that. So we're gonna go ahead and get started. So we're looking at two proportions this time. So instead of just using P and Q, we're actually gonna be using P1 and P2 and then Q1 and Q2 and then all of that. So it's really the same thing as the last chapter, except now it's with two proportions. So a couple of notations. I'm only gonna write it with one of them. I'm gonna go ahead, I'm gonna block this out real quick. I'm gonna go ahead and write out the notations for the first one, and then it really is the same thing for the second one. Okay, so for the first one, it is N1, which is the sample size of first data, like the first data set. I'm not gonna write data set, but it's really much like the first data set because of the one. Okay, and then we have X1, which is the number of successes of a first data set. Okay, and then it goes on to P1, which is the population proportion. Spelled that wrong. Population proportion for first data, or a first data set. And then we have P1 hat, which is the sample proportion of first data set. And then we have Q1 hat, which I'm just gonna write is 1 minus P1 hat. Okay, it's the same thing, it's the not successes. Okay, this goes the same for, and I'm not gonna write it all out, but I'm gonna say same goes for, and I'm gonna put it in a bracket. I'm gonna write N2, X2, P2, P2 hat, and Q2 hat. Okay, they're exactly the same thing. I just figured it goes out the same thing. Okay, so we're going to talk about something called pooled. Pooled is a formula, and what it is, it's combining two samples into one proportion. So the way we use it, we use a P, but now we're using it as a P bar. It's like X bar, but really P bar. So what this is, it combines two samples into one proportion. And the formula is P bar equals X1 plus X2 all over N1 plus N2. And that's really it. It's just combining two values on top and two values at the bottom. Okay, now what are my requirements for when I do this? It's actually the same requirements as proportions from before, except there's one added in. So the first one is that both data have to be SRS, simple random samples, for both of them. Okay, the second one you guys already know is N1 times P1 is greater or equal to 5. And N2 and P2 is greater or equal to 5. So notice you're gonna have to check this for both data sets, not just one anymore. Okay, and then the same thing, it's gonna be N1 Q1 is greater or equal to 5, and then N2 P2. Oh, I already did that one. Or Q2, sorry, is greater or equal to 5. Okay, and so this is what you've already learned. Now the third one is just an added, like, okay, well, if we're looking at two data sets, we just have to make sure they are both independent of each other. And that's the third thing you have to check, and that's because there's two data sets. So you want to make sure that they're independent of each other. Okay, the next thing is we're looking at the test statistic, or your z-score if you want to look at it. So we're going to be using our z-score formula. Again, it's, if you remember the formula, it's P hat minus your P. So in this case, since we're looking at two data sets, it's going to be P1 hat minus P2 hat minus, and then P1 minus P2. Okay, now a little note is usually if your HO is P1 equals P2, usually this is 0. So I'm going to say 0 usually. And in this case, it usually is 0. Okay, it's going to be all over. And if you remember your proportions, it's the square root of PQ all over N. But since this time there's two data sets, it's going to be a really big square root. And instead of doing P1 and P2, we're actually going to do P pool and Q pool all over N1 plus P pool Q pool all over N2. And I'm gonna have you guys go ahead and look at these two values. These are actually the same. Okay, they're pooled. Okay. And yeah, that's pretty much how you do this. So if you're doing this by hand, you're gonna first find your z-score, and then you're gonna go ahead and use normal CDF. And that'll tell you your p-value. Okay, how do you find confidence interval? Okay, so you're gonna find confidence interval, if you're gonna do this by hand. Okay, well, what requires a confidence interval? Confidence interval requires your margin of error. Okay, and how do you find your margin of error? Excuse me. You're gonna use this to find, I guess, to find your test statistic. And so your formula is E equals your Z of alpha over 2 times, and I don't want to write it all, I guess I can write it out. It's times all of this. So it's going to be P1 hat minus P2 hat minus P1 minus P2 all over square root of P pool Q pool all over N1 plus P pool Q pool all over N2. Okay, and then you use that finally, and you do, it's P1 hat minus P2 hat plus or minus E. And that tells you your confidence interval. Okay, if you're doing this by calculator, what are we going to be using? Well, if you look at all the tests, this is proportion, and there's 2 of them. So you're going to go ahead and do 2 prop Z int. Okay, and then you remember you always have to write out everything. So we're going to do an example of this, and then we're going to go ahead and solve the problem. Okay. Okay, so hypothesis test. For tests for a hypothesis made out of 2 population proportions, we consider only tests having a null hypothesis of P1 equals P2. Now, if you think about it, how do I move P2 to the other side? Is I'm going to subtract both sides by P2. So sometimes you can see as P1 minus P2 equals 0. These are actually the same. Okay, if you think about it, they're exactly the same. I just moved the P2 to the other side. Okay, so your HO is either P1 equals P2, or your HO is P1 minus P2 equals 0. And you don't have to write both of them. Just kind of stick with one of them and kind of keep going. I know some students just like keeping the equal sign there, and that way you don't have to worry about the minus sign. That's perfectly fine. Okay, so proportion of cars with rear license plates only. Are the proportions the same in Connecticut and New York? Table 1. In the chapter problem includes 2 sample proportions of cars with rear license plates only. And I didn't really give you the table. I kind of just wrote that important information out. So this is Connecticut, and that's P1 hat. So if you think about it, this is your numerator. So that's your X1. And this is your denominator, which is N1. And then P2 is your New York. So this is going to be X2, and this right here is N2. And why did I put equal signs is because I just want you to round to the 3 decimal places, so it makes your life a lot easier. If you want to keep it exact, you can. I'm just going to keep it like this. And this is going to be your, these are going to be your P1 hat and your P2 hat. Okay, so we're going to go ahead and use a significance level and a p-value method to claim that the Connecticut and New York license plates have the same proportion of cars with rear license plates only. Okay, we're going to do an entire problem. And if you look through these notes, there's just a lot of examples and very little notes. And that's kind of how I've been teaching you guys. So we're going to do this problem all the way through. So we're going to start with the state part. Okay. And again, I'm going to do the do part in 2 different ways. You get to pick which way you like to. Okay, so for the state, we actually have to go ahead and write out the proportions and the variables. So we're going to write P1 equals proportion of cars in, I'm going to write Connecticut as CT with rear license plates only. Okay, if that's P1, then P2 is going to be proportion. And yes, you do have to do this if you remember. You've been writing out the variables and what they stand So proportion of cars in New York with rear license plates only. Okay, and then I also write the ho. So my ho is that the proportions are equal to each other. And my ha, if you read the problem, it doesn't say less than or greater than, it just says that they are the same. So remember your ha is if it doesn't tell you less than or greater than, it's gonna be P1 is not equal to P2. Okay. All right, so that's your state part. Let's go ahead and do our plan part. Our plan part is our checking. So first of all, is this a random sample? Well, since it's taken from the book, I'm gonna assume it's an SRS, and I'm just gonna say book problem. Okay, I'm guessing it's a simple random sample for both. Okay, the next one is, are they independent of each other? Well, if you think about it, they have to be, because guess what? They're from different states. So different states automatically, like, they're independent of each other. Dependent is if it was like, if I was looking at the husband and looking about something in the wife and looking at something like that. You'll see that later on in the next section. Okay, the next thing I want to check is that they're all greater than or equal to 5. So I'm going to start checking it here. So I'm going to say N1 times P1 hat, which is going to be 2019 times 239 over 2019, which is 239, which is greater or equal to 5. Okay, if I do the same thing and I do like N1 and Q1 and then all of that, I don't really have to do all that math. All I have to do is do 2019 minus 239, which I didn't do. So 2019, so I'm going to clear this out. 2019 minus 239, I get 1780, which is greater or equal to 5. Why am I doing it like this? Because if you notice, these two cancel out each other. So this right here, it doesn't matter, like, the number, it's automatically going to be that. It's a little shortcut if you want to think about it. So that's the N, like the first sample. Then I have to do it for N2. So I'm going to do N2 and Q, or P2 hat, and I'm going to get 550 times 9 over 550, which is 9, which is greater or equal to 5. And then I'm going to do 550 minus 9 to get the Q part, which is 441, which is greater or equal to 5. Oh, sorry, 541. And they're good to go. So I'm going to say all conditions are met. Okay, and we're done with the state and the plan part. So we're actually halfway done with the problem. Our next part is our do. And again, I'm going to do this by hand and by calculator. Now, if you're doing this by hand, it's not a big deal. It's just there is, again, more work. So I'm going to go ahead and do it by hand. So if you're doing it by hand, the first thing I want to do is I want to find the pool value. Okay, so I'm going to do P bar is equal to, and I'll write the formula out. So X1 plus X2 over N1 plus N2. So X1 is 239 and X2 is 9. And N1 is 2019 and N2 is 550. I'm just going to use my calculator. Now, be careful when you're using your calculator. You just have to make sure there's parentheses. So 239 plus 9 divided by 2019 plus 550. And I'm going to round to 3 decimal places. So 0.097. Okay, and again, this is you doing it by hand. So if this is your P bar, what's your Q bar? Well, that's just 1 minus 0.097, which is 0.903. Okay, and I'm going to use that a lot in my formula. So we found our P value and our Q value. We're going to go ahead, I'm going to keep it the same color, your Z-score. So remember, your Z-score formula is P1 hat minus P2 hat, in a parentheses, minus P1 minus P2, all over the square root of P bar Q bar over N1 plus P bar Q bar over N2. All right, again, you don't have to write the formula for every single thing. I'm just writing it for you guys because that way you can kind of reference it. So I'm gonna go ahead and fill this in. So P1 hat, we actually found this to be 0.118 minus P2 hat was 0.106. And then I did write like our P1 minus P2, and if you think about it, that's really your ho, and if I move the P2 to the other side, and you also wrote this, is going to be 0. And you're always pretty much assuming that it's 0. all over the square root of parentheses 0.097 times 0.903 over 2019 plus 0.097 times 0.903 all over 550. And yes, I know it's a lot. Again, we're gonna kind of do this. I'm going to go ahead and use my calculator very carefully and see if I can get the answer. So I'm gonna do parentheses 0.118 minus 0.016, close my parentheses. I don't have to include the minus 0 because anything minus 0 is 0. And then I'm gonna hit divide and I'm gonna open another parentheses and I'm gonna go ahead and write my radical stuff. So parentheses 0.097 times 0.903, close it, divided by 2019, plus point, in parentheses 0.907, 097, oh, that would have been bad, plus 0.903 divided by 550. And I got 7.165. Okay, and what is that? That is your z-score. So same thing as before. And then how do I find my value? Well, we're gonna go ahead and use normal CDF. And I'm gonna do, since this is technically two-tailed if you think back to the last chapter, so we're gonna take this number and multiply it by 2. But since this is towards the right, we're gonna go ahead and do 7.165 to 1,000, 0 and 1. And I'm gonna multiply this by 2 at the end. Okay, and I'm gonna go ahead and label this as lower, upper, mu, and sigma. All right, so I'm gonna do normal CDF of 7.165 to 1,000, 0 and 1. And I'm gonna take this answer and multiply it by 2. And again, a lot of students, what they do is they don't see this e to negative 13. That means that it's a power of 0.000 12 times until you hit the 7. So this is going to be 7.836, I can times 10 to the negative 13. Okay, and this right here is your p-value. So do you reject HO or fail to reject HO? Well, if you think about it, this is really small, so you're actually rejecting the HO. Okay, this is by hand. I'm gonna go ahead and do this by calculator again. So by calculator, okay, you're going to go ahead and do a 2-prop z-test. So before we did 1-prop z-test, now we're doing a 2-prop z-test. So I'm gonna go ahead and go to my stat, go to tests, 2-prop z-test is number 6. And I'm gonna go ahead and enter in my data. Okay, so I'm gonna write x1 was 239, and yes, I'm going to go ahead and write it in. N1 is equal to 2019. X2 is equal to 9. And N2 is equal to 550. And then I'm gonna say P1 is not equal to P2. I'm gonna hit calculate, and I'm gonna write out the important information. So I'm gonna write z equals 7.182, which we're really close to that, it's not exact. And I'm gonna say my p-value is equal to 6.941 times 10 to the negative 13, which again, it's not like you're like, oh, they're pretty far, but remember, this is 0.00000 that many times. I don't have to write the P1 hat, P2 hat. I don't have to write the P hat right there. I can just leave this alone and I'm good to go. Okay, so this is pretty much the important info I wanted. I have my z-score and p-value is essentially what it is that I want. Okay, my conclude part. Now, if you're doing it one way or the other, you're gonna get different answers. But I'm gonna go ahead and just put p equals, and I'll just pick this one, 6.941 times 10 to the negative 13, which is less than or equal to alpha, so you reject HO. And I'm gonna go ahead and write my sentence. There is sufficient evidence to conclude that the proportions of rear license plates only are not the same in Connecticut and New York. So I'm talking about the HA being true, but I kind of want to talk about what do the each P stand for. And that is the end of example 1. Okay, let's go on to a little bit more notes, right? Or no, we have example 2, and then we have a little bit of notes. Okay, so example 2, it says use the sample data given in example 1 to construct a 95% confidence interval to estimate the difference between two population proportions. Okay, what does the result suggest about the data claim Connecticut and New York have the same proportion of cars with rear license plates only? Okay, so again, I'm going to do this by hand in my calculator. I don't have to do the state part because it's the same example. I don't have to do the check part, so the do part, or plan part. We're going to go ahead and just do the do and conclude. Okay, so again, I'm going to do this by hand, and I'm going to do this by calculator. So by hand, I'm going to write the formula out. So E is equal to Z of alpha over 2 times the square root of P1 times Q1 over N1 plus P2 Q2 over N2. Okay, so if this is a 95% confidence level, your Z is 1.96. It's the same as before. So I'm going to go ahead and do 1.96 times the square root of, and I'm going to go ahead and do P1 and Q1. So I just did 239 over 2019. And there's multiple ways to do this. I kind of just did it this way in my notes. So I'm going to just go ahead and keep this. So this is Q1, which is technically 1 minus 239 over 2019. So this is really 1 minus 239 over 2019. So you can write the decimal if you want. I'm just doing the fraction version, which is 1780 over 2019, all over 2019. And this is a really big square root. I can't emphasize that enough. Okay, plus 9 over 550 over 541 over 550. Oh, my writing is horrible. All over 550. Okay, and I'm going to go ahead and get that value. So I'm going to do 1.96 times the square root of 239 over 2019 times 1780 divided by 2019, all divided by 2019, plus, and notice it's all still in a big square root, parentheses 9 divided by 550 times 541 divided by 550, all over 550. Cool. And I got 0.018. Okay. So let's go ahead and that's our E value, but we're asked to find our confidence interval. So remember, the confidence interval is P1 hat minus P2 hat plus or minus your E. Okay, so your P1 hat is 239 over 2019, and your P2 hat was 9 over 550. And I'm going to add and subtract 0.018. Okay, so I'm going to do parentheses 239 over 2019 minus parentheses 9 divided by 550, and I'm going to do plus 0.018. Okay, and that gets you your upper. To get your lower, again, you can do, I'm going to do a trick, and I'm going to go ahead and just change this to a minus, and I'm going to get 0.084 and then 0.120. Okay, and this is my confidence interval. Okay, this is by hand. Let's go ahead and do this by calculator. Okay, so by calculator, you're going to be using a 2-prop Z int. So we did 1-prop Z interval before, now we're doing 2-prop Z interval. Okay, so we're gonna go ahead and find that. So I'm gonna do stat tests 2-prop Z int, which is letter B. And I'm gonna go ahead and type in the information. The nice thing, it's already there. So I'm gonna write X1 is 239, N1 is 2019, X2 is 9, and N2 is 550. And my C level is actually 0.95, so I have to change this to 0.95. I'm gonna hit calculate, and I'm gonna get some values. So I get 0.084 and then 0.120. So I actually got the same answer. P1 hat, P2 hat, I have to write one, and N2 I got. So I have my confidence interval. Okay, so we're gonna go ahead and write our sentence. We are 95% confident that the interval from 0.084 to 0.120 contains the true proportion of the difference. So we're technically, so the difference between New York and Connecticut population proportions of rear license plates only. Of rear license plates only. I don't know, something like that. But the question asks, what does the result suggest about the claim that Connecticut and New York have the same proportion of cars near license with rear license plates only? So I just want you to think about this. If you think about it, like if these both numbers are both positive or they're both negative, that means that 0 is not in between it. So if this, like these are both positive, so that means that 0 is not in between it. And if you think back to the last part, our hoe, if I go to the last set of notes, our hoe was that they were the same. And that means that like 0 has to be in it, right? Because 0 equals 0. Or if you subtract these two numbers, it should be 0. And it wasn't, okay? 0 is not contained in here. So I'm going to write a little bit of like, what does this really mean? So I'm going to say, since the interval doesn't contain 0, okay, we would reject the hoe. Okay, so you actually would reject the hoe because it doesn't contain 0. If it contains 0, we would fail to reject it because 0 is contained in it. Okay, and then it would be the same sentence as the front. So I'm going to say there is sufficient evidence. And then I'm going to write ... But you can't write that. You can write it out. It's the same sentence as the front if you want to make a note of that. Okay. So here's a little summary, and then again, I do a couple more questions. So for confidence interval, your final answer should be P1 hat minus P2 hat minus E, and then it's going to be P1 hat minus P2 hat, P2 hat plus E. Okay, so this is the only part that changes. Everything else stays the same. Your margin of error is E is equal to Z of alpha over 2 times the square root, okay, of P1 Q1 over N1 plus P2 Q2 over N2. And then it says confidence interval formula. Guess what? We already did it. And then the margin of error formula, we did it. All right, what was your pooled sample proportion formula? That's P bar equals X1 plus X2 over N1 plus N2. Okay, if you're using, and this is for just confidence interval, if you're using a TI, you're going to be using a 2 prop Z int. Okay. If you're not, you're going to have to find your E value and add and subtract your proportions, which again, you're more than welcome to. Okay, for your critical values, this is really your Z-score. This is essentially what you're going to do is you're going to do a 2 prop Z int. Oh, sorry. 2 prop Z int. Or we're going to do 2 prop Z, 2 prop Z int. It's the same thing. It's the same calculator. A critical value is just your Z-score. And to find your Z-score, you use normal CDF. Okay, if you want to find out your Z-score. All right, so let's go on to some hypothesis testing, and then we'll do a couple of more examples, and then that's the end of the notes. All right, so two-tailed. Do you guys remember what to do for two-tailed or what your hoe is? So remember, your hoe is P1 equals P2. Okay, your ha, if it's two-tailed, is P1 does not equal P2. Okay, now you could write it a different way. And again, you stick with kind of one of them. I usually stick with this one, but I want to go over both. So it's P1 minus P2 equals 0. And your ha is P1 minus P2 does not equal 0. Okay, either or is accepted. I kind of just stick with this one. I'm going to just write them all out for you so you can kind of see the difference. So your right tail test is essentially when it's to the right. Okay, your ho is P1 still equals P2. And your ha is P1 is greater than P2. Okay, or your ho is P1 minus P2 equals 0. And your ha is P1 minus P2 is greater than 0. So all I'm doing is moving the P2 to the other side. Okay, and then our left tail, okay, is our ho is still P1 equals P2. And our ha this time is P1 is less than P2. Or our ho is P1 minus P2 equals 0. And our ha is P1 minus P2 is less than 0. Okay, if you're using a TI calculator, you're going to do a 2-prop Z test. And this is what I was trying to write in the front. I struggle a little, or yeah, in the front of this paper. And then use normal CDF. Okay. If you're trying to find the formula for to find this, you're gonna do Z equals. No, actually, you don't have to do normal CDF. You do normal CDF for this part. For this one, you just write this out and then you write everything out. Write everything out. Okay, so for this one is the one where you do P1 hat minus P2 hat minus P1 minus P2. And usually what is this? This part's usually 0. All over the square root, and it's a big square root, excuse me, of P pool Q pool over N1 plus P pool Q pool over N2. Okay. And then you use normal CDF to find it. If you're using normal CDF for the value, just note for 2-tail, what do you have to do? You have to multiply by 2. Okay, if it's left tail or right tail, you just have to write left tail or right tail, but if it's for that one, you have to do that. All right, so let's go ahead and do an example. So it says, consider the chart below. Find a 99% confidence interval for the difference between the two population proportions. Okay, so a little heads up. I'm going to do this by calculator because it's a lot quicker. You're more than welcome to do it by hand. I'm going to write out the formula by hand over here, but I'm not going to actually do it. If you want to do it, you by all means, go for it. I'm not going to. I'm just going to do it by hand, or by calculator. So by calculator, I'm going to go ahead and write what test I'm doing, so 2-prop Z int, and I'm actually going to go to it and see what I have to write out. So I'm going to go to calculator tests 2-prop Z int. Okay, and then I'm going to write out the important information. So I'm going to write x1 is 50, x2 or n1 is 84, x2 is 40, and N2 is 76. And this time we're doing a 0.99% confidence level. So I'm like writing it out as I type it out. Okay, I'm gonna hit calculate and I'm gonna write negative 0.1331. Since it's 4 decimals, I might as well just write all 4. Okay, and that's all I ask because I have to find the 99% confidence interval. Now the sad thing is I didn't leave enough space, but you're gonna write your sentence. If this was an actual question, this is just more practice of like using your calculator. So if you wanna just write like practice question, you can, to see if you get the same answers. Okay, now if you're actually doing this by hand, you're gonna do P1 hat minus P2 hat. So you actually have to calculate that. So remember 50 over 84 and 40 over 76. Okay, that's gonna be your first part. Sorry, you're gonna add and subtract your z-score value. So you have to do z of alpha over 2, which you can use the chart from before, times the square root of, and it's going to be P1 hat, Q1 hat over N1 plus P2 hat, Q2 hat over N2. And so that's this part right here is your E. Okay, and you should get about the same answer if you were to do this by hand. Okay, your Z-score, if you don't remember it, is 2.576 or 575, however you want to look at it, but that's going to be your Z-score for 99%. Okay, so let's go ahead and test the claim that P1 is greater than P2. So if you think about it and you look at this, this is a right tail test. So I'm just going to write right tail. Okay, just to give myself a little note. We're going to go ahead and do everything. I'm not going to do the state part just because it's just going straight into like an example. We do a full-on one on the next page. But let's go ahead and write our hoe. So our hoe is P1 equals P2. And again, you can write it either way. I'm just going to kind of stick with one. My ha is P1 is greater than P2. Okay, I'm going to again do this by hand and by calculator. So by hand. Okay, so let's go ahead, and I'm not going to write out the formula anymore. You guys have the formula. It's going to be 50 over 84 minus 40 over 76 minus 0, all over, because it's this part first, all over the square root of, and we have to find the pooled version. So we didn't actually find that out yet, so we're going to find pooled is 50 plus 40 all over 84 plus 76. And I already calculated it. It was 0.5625. I'm just going to write it in 4 decimals because it was really simple. I already did it, so I got that. Okay, so I'm going to go ahead and fill that into the formula. So I'm going to do 0.5625 times 0.4375 all over 84 plus 0.5625 times 0.4375 all over 76. So you have all of this on top of all of this, and I get 0.878. And what is this called? This is called your Z-score. Okay, that is not your p-value, that's your Z-score. So your next thing is you have to find your Z-score, and how do you do that? You're going to use normal CDF. And since this is a right tail test, okay, you want this number to the right. So your minimum is 0.878, your maximum is 1,000, or upper is 1,000, and then you have 0 and 1. That's right, this is lower, this is upper, this is mean, and this is sigma. So I'm gonna go ahead and write out my values. So I'm gonna put 0.878, 1,000, 0, and 1. And I get 0.190 actually, because everything rounds up. Okay, so let's go ahead and write out by calculator. I know I'm running out of space, so I'm gonna do this by calculator. And this is going to be a 2-prop z-test. All right, so I'm gonna go to the 2-prop z-test, and I'm gonna go ahead and look it out. So 2-prop z-test, and I'm gonna write out the important information. The nice thing is, once you do interval, it's the same thing as test. Like it already figures out the data. So 50, 84, 40, 76, but P1 is actually going to be greater than P2. And I'm gonna go ahead and write my calculate. And I got Z to be 0.878, which is exactly what I got here. So I kind of knew I did it right. And P is equal to 0.9190, which again, very close, actually what I got over here. Okay, now let's go ahead and write our sentence. Since P equals 0.190, which is greater than alpha, what do we do? Because alpha is 0.05. If you don't you're not giving it to it, you're going to fail to reject hoe. There is no sufficient evidence. And then, like, we don't have our ha in terms of words, so we're gonna say there's no sufficient evidence that what? P1 is greater than P2. Okay, and I would actually put it in context of words, but I can't because there's no words to this. It's just our symbol. All right, we have one last example. I would say try to pause the video and try it out yourself and then go from there. But if you want to, you can go ahead and try it out yourself if you want. So it says in 2012, the general surveys asked 1,343 employees people between the age of 18 and 50 whether they used a computer in their work, and 916 said that they did. In the year 2008, they asked the same question of an independent sample of 615 and 465 said that they used a computer at work. Assume that these two are random samples from the population of employed people. Can you conclude that the proportion of people who used a computer at work was greater in 2008 than 2002? Use the 0.05 significance level. This is like a question that you would see like on an exam. Like notice, very, very like straightforward. All right, so we're gonna have to do all the parts. Okay, again, I would say pause it and see if you can do it. So I'm gonna go ahead and do the state part. Okay, so state is going to be, we're gonna have P1 equal proportion of employed people that said they used a computer in 2002. Okay, P2 is proportion, and yes, I know it's annoying, proportion of employed people that said they used a computer in 2008. Okay, and then what else goes in my ho and my ha? My ho is my P1 is equal to P2. My ha, this time it actually said people used a work was greater in 2008. So since P2 is 2008, we want this one to be greater. So we're essentially saying that P1 is less than P2. So if you think about it, we want P2 to be greater, and P2 is 2008. And so we're going to say our ha is going to be less than. So is this left-tailed or right-tailed? This is actually going to be left-tail. Okay. All right, our plan part. Okay, our plan part. SRS, well, it says independent sample, but it also said random samples. So I'm going to say SRS for both are yes. And I'm going to say different years equals independent. Okay, and then last one, we're gonna go ahead and check if everything is greater or equal to 5. So again, you can use the trick that I kind of talked about. So you can say 916, because that's how many people said yes, is greater or equal to 5. And there's a total of 1,343 employees. So you can figure out from there what's the difference. So if I do 1,343 minus 916, I get 427, which is greater or equal to 5. And then you do it the other way. So you're going to say out of the 615, 465 said yes, and that's greater or equal to 5. And if you subtract that, you get 150 is greater or equal to 5. So all the conditions are met. And notice I mixed up the order in terms of checking. You're more than welcome to mix up the order. All right, our do part is you're going to go ahead and do this by hand or by calculator. If you're going to do this by hand, a little heads up, you do have to find your pooled version. I'm not going to do it by hand. You can do it by hand. I was like, I'm going to do this by calculator and just see if you get the same answer or around the same answer. I actually can write out both answers. I did it by hand in my key, but I'm not going to do it by hand. And then by calculator, again, the same thing. So I'm going to do this one. So 2 prop z test. And I'll write out the important information. So x1 is 916, n1 is 1343, x2 is 465, and n2 is 615. P1 is less than P2. My z-score was negative 3.336, and my p-value was 4.256 times 10 to the negative 4, which is 0.000425 if you think about it like that. Okay, if you're doing this by hand, I got my pooled value to be 0.705. Again, I'm just going to write out the answers. I did this by hand too. I got my z-score to be negative 3.335, which is very close to what I got. And then I did normal CDF, and I used negative 1,000, negative 3.335, 0, and 1. And I got 4.266 times 10 to the negative 4. So very close, But yeah, I did want it. I was like, I'll do it by hand, but give you the answers. I do want to see the work if you're doing it by hand. If you're doing it by calculator, this is actually good enough. If you're doing it by hand, you have to show all your work. Okay. All right. So our last part is our conclude. So I'm going to say P equals 4.266 times 10 to the negative 4. It doesn't matter which one you pick, is the one you did, which is greater or equal to alpha, so you reject ho. I'm going to say there is sufficient evidence. Sufficient evidence that the proportion of people who used a computer at work was greater in 2008 than in 2002. Something where it talks about the ha. Okay, and that's the end of the first section. It's actually the longest section.